Welcome! In this video I want to introduce you to the concept of network effects. To understand what network effects are, we first have to remind ourselves about the idea of economies of scale and what economists mean by the term externality. Sounds complicated? Don't worry. I will walk you through a bunch of examples. There are two types of economies of scale. You might already be familiar with supply-side economies of scale. The idea is really simple. The more you produce, the more efficient you get at producing. It is often the case that larger firms have lower costs per unit. But how? One way to think about it is that dynamically, over the product lifecycle, firms invest more in process innovation and therefore costs are reduced over time. There can also be learning by doing. Often supply-side economies of scale have a natural limit. As a result, in industries with supply-side economies of scale, we often see an oligopolistic market structure of 3 to 4 firms. The car industry is a good example. A few firms cover a large majority of the market. Contrast that to the idea of demand-side economies of scale. Also here, large firms have an advantage, but for a different reason. The more users, the larger are the benefits to the individual user. Think of the telephone. If I'm the only person with a phone, there's no use for it. But if more people have one, it becomes more and more useful. How much value I get out of using a product is bounded by the size of the market. As a result, we often see temporary monopolies where one firm controls the market, at least for some time. The IT and telecommunications sector is a good example. The key aspect that makes economies of scale work are externalities. What is an externality? It is when the action of an economic agent, a producer or a consumer, affects other agents in a way that is not reflected in the market price. The classic example is air pollution. The price I pay to drive a car does not include the damage that I cause to the environment by emitting CO2. Nevertheless, through my private consumption of driving, I affect everybody on the planet. When there are externalities, often governments intervene to internalize the externality. For example, by charging higher taxes for cars with larger CO2 emissions. Now it is more costly to drive a car, and I have an incentive to take the train more often. What does this have to do with economies of scale? Well, by getting a phone, I'm creating an externality. This time it is a positive externality. It is not only that I get value from being able to communicate with my friends, but also my friends get value from being able to communicate with me. Externalities that happen on the demand side are very often due to networks of users. This is why we speak of network externalities, when a product's or a technology's benefits to each user depend on the number of other users. Network externalities create demand-side economies of scale. The nature of competition is very different in markets with network externalities. We often see markets where the winner takes all, or at least most, meaning one or few firms dominate the market. As a consequence, you rather see competition for the market than competition in the market. Firms compete to become the dominant player in a new market, rather than that they compete in an existing market. Back to the example of the phone. It's the example of a network good. Let's have a look at a few stylized facts. First, each user needs other people to communicate with, meaning that if no other users have phones, there's no point in getting one. Second, the infrastructure needs to be built in advance, prior to people using the phone. Therefore, starting a telecommunication network involves certain risks. Third, in many countries, there is not one, but a few firms that operate telecommunication networks. However, the networks of different firms work on the same standard and are fully compatible. Finally, it can be quite difficult or costly to switch between different operators. It turns out that most of these characteristics are generally true for any network industry. Now that we know what network externalities are and what kind of market structure they tend to generate, let's go into more detail. Network externalities can be created by two types of network effects. The first one is a direct network effect. Like in the phone example, we speak of direct network effects when the utility derived from consumption of a network good is affected by the number of other people using similar or compatible goods. The utility increases when there are more users to interact with. Having a phone only makes sense if there are other people to communicate with. The utility increases in the number of possible interaction partners. It turns out that this increase is exponential. Let me illustrate this. On the x-axis, you see the number of users in the network, and on the y-axis, you see the number of possible interactions between those users. Let's now simulate the growth of the network. The number of possible interactions grows really fast. A network with only 10 users has already 90 different possible interactions. Utility increases disproportionately with network size. What is the second type of network effect? In some cases, network externalities matter indirectly. The utility that I get from using a product depends on the availability of complementary goods, which in turn depends on the number of potential buyers. Indirect network effects are often found in system goods like operating systems and application software. The value you get from buying a video game console depends a lot on the games that you can play on it, right? The number of users and the number of complementary goods interact dynamically. Each increase in complementary goods or users makes the other side stronger. As we have more users, we will attract more producers of complementary goods, and as we have more complementary goods, we are attracting more users, and so on. It is a cycle that reinforces itself. What are the implications of direct and indirect network effects for product design? It turns out that network markets are often subject to a chicken and egg problem. For the network good to become really useful, either through direct or through indirect network effects, somebody else needs to use it or make complementary goods. But why should I go first and risk that nobody follows? This sounds like a tough problem, and it is. We can try to solve the chicken and egg problem by strategically making our product compatible to products that are already on the market. In this way, we can benefit from network effects of an installed base of users. Compatibility is achieved by fixing a number of product characteristics such that products are interoperable. With perfect compatibility, network effects are equalized across technologies since users of all networks can make use of the other networks. But hold on. Compatibility choice is a double-edged sword, since desirability of compatibility often changes over time. Once we have a large enough installed base of users, we want to make sure to decrease compatibility with competing products. This makes our product more unique and helps to secure our competitive advantage. How about we look at a case study to let the strategic implications sink in? Fasten your seatbelt, we're going to travel back in time. Welcome to the mid-80s and early 90s, back when computer software used to look like this. We are looking at a specific application, spreadsheet software. This was the killer application because it allowed professional users to make their accounting, controlling, and production planning so much more efficient. Back in the days, the industry standard was not Microsoft Excel, but almost everybody used a program called Lotus 1-2-3. They had a 70% market share. The rest of the market was more or less equally divided among a few other software packages. What is interesting is that some of those other programs were compatible in the sense that you could open Lotus files. In fact, over time, more and more of Lotus competitors chose to be compatible. In 1986, about 50% of the available spreadsheet applications were compatible to Lotus. In 1989, 90% of the applications in the market could read Lotus files. However, it looks like after 1989 there's a decrease. So what happened? Before 1989, everyone who wanted to be compatible could do so because Lotus published its file format specification. But then, after 1989, Lotus changed the rules of the game. If you wanted to be compatible, you needed a license agreement. So being compatible became costly for other firms. And this can explain the decrease in number of compatible software packages. Now, file format is just one way to make software applications interoperable. If you think about it, oftentimes the reason why you keep using an app is because you know how to use it. Switching to another app seems costly because you need to learn how it works. How can product design make it easier to switch? Well, by mimicking the look and feel. It turns out that Lotus was quite aggressive in trying to prevent user interface compatibility. They sued rivals when the user interface was too similar. These legal procedures went up to the Supreme Court in the US, and it became a landmark case for intellectual property rights in software. As a result, firms were put out of business because it became too costly and risky to have a user interface that was compatible with Lotus. After 1989, the market share of Lotus declined. Maybe introducing licenses only in 1989 was already too late? Not to mention that it was only in 1996 that they won in the Supreme Court. It's more complicated than that. As Lotus market share decreases, a familiar name starts to become more and more successful. Microsoft Excel. What explains Excel's rise to the top? Is it compatibility or some other form of indirect network effects? Take a moment to think about operating systems. Before 1990, computer screens were nothing but black boxes with lines of text. Graphical operating systems and a new device called mouse were a true game changer. Which was the most successful graphical operating system? Windows. And who makes Windows? Microsoft? Well, of course they had elite knowledge and therefore could use the features that the new operating system enabled much more easily than competitors. Thus, Microsoft Excel's rise to the top might have to do with indirect network effects coming from the Windows operating system. What do we learn from this episode of Software History? Was free file format compatibility a mistake for Lotus? What would have happened if Lotus had started licensing rivals earlier? The returns to compatibility depend on your market share. If you have a small market share, you want to be compatible with whoever else is in the market. As your market share increases, your returns to compatibility increase. But only up to a point. Once you have become the dominant player in the market, you don't want to be compatible anymore. This is when your rival starts to steal users from you. Now, what about licensing revenues? The bigger your market share is, the more you can make from selling licenses. Many competitors will want to be compatible with you. By charging a positive licensing fee, you can offset the negative consequences of losing users, because in return you get licensing income. To sum up, in this video we introduce demand-side economies of scale and the role they play in network industries. Now you know a lot about network effects and the differences between direct and indirect network effects. We saw the strategic implications of compatibility and indirect network effects in the case of Lotus 1-2-3 and how they lost the market to Microsoft Excel. And this is it for now. Thanks for watching and see you in the next video.